bit nervous. So good afternoon, I'm Sia, and today I will talk about brains in sync during dialogic reading. So first, a bit of recap on what dialogic reading is. It is a form of interactive chat reading that uses 4 strategies, known as PEER, which stands for prompt, evaluate, expand, and repeat. So as I said, a recap, prompt is where parents ask children to talk about the book. Evaluate is where parents give feedback to children after they have talked. Expand is where parents elaborate on what children said. And repeat is where parents ask children to repeat certain words or phrases after them. And prompts can be further broken down into the crowd strategies known as completion, recall, open-ended, WH, and distancing. So completion is where parents leave a sentence hanging for the child to complete. Recall is where parents prompt children to think about what happened in the book previously. Open-end is where parents prompt children using open-ended questions that do not have one definite answer. WH is where parents prompt children using WH question markers such as what, why, who, when, and how. And distancing is where parents prompt children to relate what they have been reading in the book with their own experience. So why do dialogic reading? One important point that we notice is that dialogic reading is used naturally with young pre-verbal 6-month-old infants, which means that parents do know how to use dialogic reading. But do we know the full benefits of dialogic reading? To some extent, yes. For instance, we know that with PEER, children are encouraged to talk and they are given feedback after they have talked, which means that dialogic reading has clear-cut language benefits for children. But what about the brain? So in this symposium called Books to Brains, my talk will focus on dialogic reading and the brain. So with regard to brain activation, past studies have found that shared reading experience is linked to greater brain activation. We have also heard from the previous talk that shared reading experience is linked to predictive brain signal. However, dialogic reading is about parent-child interaction. These past studies focus on single brain activation, which does not capture the essence of social interaction. So the question that we really want to ask is whether dialogic reading is linked to parent-child brain synchronization. So now we move on to brain synchronization. Now if you remember from the keynote speech this morning, brain synchronization refers to 2 social partners, if you see up there, in our case a parent and a child, activating their brains in a coordinated manner during an interaction, in our case, shared reading. So again, why do shared reading, why do brain synchronization? For us, it is important because it allows us to understand how interaction during shared reading influences early brain development. There is one study on this, and they found that parent-child brain synchronization is higher during shared reading than silent video watching. The problem is that they use 2 different tasks. So we do not know whether the difference in brain synchronization is due to the task difference. Also, they had a rather small sample size. They tested 39 dyads, which is fine, but they later split it into 2 smaller groups in their analysis. So this is where our study comes in. We aim to overcome these 2 problems, and we ask 2 questions. First, do parent-child dyads show higher brain synchronization when they read together? And second, do parent-child dyads show higher brain synchronization when they interact more while reading together? So to answer these 2 questions, we tested 68 parent-child dyads. We excluded some of them, and our final sample size was 59. 29 of them were boys, and they were about 5 years of age. So if you see, sorry, just give me a moment. Yes. So if you look at this picture here, we can see the parent reading with the child, both of them wearing the fNIRS cap, and we have the fNIRS device behind them. So all parent-child dyads have to complete 2 conditions, SBR, shared book reading, and solo. And the order of these two conditions was counterbalanced across diets. And in both conditions, the diets have to read picture books without words. So in the solo condition, they had to read alone for 3 minutes. If you can see this chart here, we can see that the parent reads a book, the child reads a book, and we place a board in between them. The FNIRS device is behind them, and we have 2 cameras to capture the whole session. And after that, they have to rest for 25 seconds where they sit there and do nothing. And in the SBR condition, they read together for 5 minutes. And you can see that the parent and the child are reading together. So to quantify reading interaction, we transcribed the recordings, we coded every sentence that the parents said, we gave them a score of 1 every time they used one of the peer strategies, and at the end we sum up the scores, and a higher score would mean more interaction. And to quantify brain synchronization, we use wavelet transform coherence, or WTC for short. It measures the coherence between parents' brain activation and the child's brain activation. And to capture WTC, we use hyperscanning, and we use the same probe set for parents and children. You can see here that the left one is for the parent, the probe set for the parent, and the right is for the child. And we're interested in 3 brain regions, namely IFG, inferior frontal gyrus, STC, superior temporal cortex, and PPJ, temporal parietal junction. So briefly, these 3 regions are involved in language production, language comprehension, reasoning of others' intentions, and executive function, all of which are required during dialogic reading when parents and children are interacting with each other. So we also pre-process our brain data, and this is our pipeline, but I won't go into detail. And now, let's move on to results. So first is whether we observe higher brain synchronization when parents and children are reading together. This chart here has several graphs, and the location of the graphs corresponds to the brain channels on this picture here. And on the y-axis of all the graphs, it shows WTC, so a higher number would mean higher coherence or higher synchronization. And each graph has 2 box plots. The one on the left shows solo condition, and the one on the right shows SBR condition. And we can see that in several channels, boxed in red here, the SBR condition has a higher WTC score than the solo condition, which means that we do observe higher brain synchronization when parents and children are reading together. So now we can ask the second question, what about interaction? Do parents and children show higher brain synchronization when they interact more? So the y-axis there shows WTC during SBR, and the x-axis shows the frequency of using completion, where parents leave a sentence hanging for the child to complete. And we found that left STC, denoted by channel 3, correlates positively with the strategy completion, which means that when parents interact with children more using completion, they tend to have a higher brain synchronization with their children. And this remains significant even after we have controlled for children's expressive vocabulary, so how many words children can say, and also parents' education level, which is an index for socio-economic status. So to conclude, we were interested in 2 questions. First is whether parent-child diets show higher brain synchronization when they read together. And we found yes, in left STC, in left TPJ, and right IFG. And if you notice, it isn't just language comprehension that is involved. It is also understanding of others' intentions and executive function, which means that we show that the benefits of interactive shared reading go beyond language abilities. And for the second question of whether parent-child diets show higher brain synchronization when they interact more, we found positively yes, at least when using the strategy completion. And we argue that this is because to use completion successfully, children need to understand what they have been reading in the book, and they need to understand what parents are saying in that hanging sentence. And before I end my presentation, I would like to share a bit of future directions. So one thing to note is that our data has limited generalizability. We tested mostly mothers, And we know also, the keynote speaker has mentioned that fathers interact differently from mothers. And so it may be a good idea to also look at fathers in the future. And for further analysis of the current study, we will be looking at synchronization between different brain regions of parents and children. And that's all from me. Thank you very much for listening.